this is Mr. Boggs. In this video we're talking about forces and friction. So we're going to start out by just talking about forces, and then we'll get into how friction affects those forces. So if we define what a force is just a push or a pull that acts on an object. Force is measured in newtons, so our units are the newton, and that's abbreviated with a capital N. And that is not like a Fig Newton, more like an Isaac Newton, who is the founder of classical physics. So now you may be asking yourself, I know what the units for measuring force is, it's the newtons, and I know what a force is, it's a push or a pull on an object. But I really have never measured anything in newtons, so I have no idea really how big a newton, how much force that really is. So if we looked at how much 1 newton is, 1 newton is equivalent to moving a 1 kilogram mass at a rate of 1 meter in 1 second every second. So if we looked at that, and we looked at an example, so we have our 1 kilogram mass here sitting on our table, and we have our trusty index pointer capable of exerting exact forces. So if we set the dial to 1 newton, we applied 1 newton of force to our 1 kilogram mass, it'll move exactly 1 meter across the table in exactly 1 second. So if you time that, it actually does move across there in 1 second. And it would do that every second. So it's accelerating at 1 meter per second squared whenever you push it across the table. So it would continue, if there were no outside forces acting on it, then it would continue on forever on that same path. So if we were in outer space, for instance, and we were far enough from the Earth where gravity wasn't pulling on us, and we applied our 1 newton to our 1 kilogram mass, it would continue to move 1 meter every second on forever until it collided with an object, so an asteroid or a planet, who knows. But since we are on Earth, we do have to think about outside forces. So if we have if we are on Earth, we have to deal with gravity pulling objects down. We also have to deal with friction, and we're going to talk about the different types of friction here in a minute. But first, let's talk about what happens if we combine forces. So if we have more than one force acting on an object, what happens to those forces? And it's pretty much common sense. It's not that hard to understand, but I'm going to give you some examples. And when combining forces or dealing with more than one force, we have to think about what is the net force. And what is a net force? A net force is just our total force. So if we added up all the forces or subtracted the forces, what's going to be our total force acting on the object? So I got some examples here. So if these 3 people are pushing on a car, for instance, so if you're moving all those forces in one direction, so you have 3 kind of smaller forces here, and the size of the arrows are going to be equivalent to the force, so that would equal 1 big force. So if we just had 1 plus 1 plus 1, that's going to equal 3. So, and remember that our units are newtons, so it would be 3 newtons, and that's just an example. That's probably not how many newtons they're actually applying. In this example, we're looking at these sumo wrestlers. So the sumo wrestlers are opposing forces, and they're trying to push each other out of the ring. This guy over here is applying a force toward that one, and this one is applying a force toward the other guy, but his force is a little bit bigger, so he's going to be winning the match here. So our overall force, so if this was 5 newtons, and we subtracted that from this one's 3 newtons, then the -2, and -2 is just giving us the direction here. We'd have -2 newtons here, so we'd be going in that direction, maybe not so fast. The third example, if 2 people are pushing on an object and they're opposing forces. So what happens if they're opposing forces and they're equal to each other? So sorry, my line should be about equal. Then our net force, our total force at the end, is going to be 0. So that's pretty common Common sense to think about. It's not too hard to think about combining forces, but you need to know what our net force. So if you hear me say what is the net force, I'm just talking about the total force at the end. So getting into the types of friction and how they affect forces. So friction is a force that opposes the motion of objects that touch. So whenever you have two objects that are touching, you're going to have friction. So going back to the same example, what is happening, and we'll get into the types of friction. Actually, the bell is ringing here. So we have static friction in between this one, and static friction is just friction that keeps objects in the same place. So the friction will be in between the bottom and of the weight and the table. So if we were able to apply a force to overcome static friction, then we would have static friction. So static friction is the friction in between the table and the object as it's moving. So it has two flat surfaces and they're moving across each other. If we turn that weight over on its side and we rolled it across the table, then we would have rolling friction. And rolling friction actually reduces the amount of friction because as it turns, you're actually creating static friction in between different points along the edges here. So if we rotated it, it would rotate and you'd have static frictions around there. That's why we use wheels, because it reduces friction quite a bit instead of say skis on our cars. The last type of friction would be to think about is fluid friction. And that is not only just between objects and water, but you can also think of the air as a type of fluid friction. So if you've ever swung a tennis racket through the air, you're experiencing fluid friction. Or you went skydiving, you have friction in between the air molecules and your body. All right, so that is forces and friction, and hopefully that was helpful, and I'll see you guys next time.